Today we'll be discussing the topic of work. Work equals pressure times change in volume. Now, there are three processes. There is an isothermal, isobaric, and adiabatic. Now, there is an isochoric process, but not for work, because work is the change in volume, and since isochoric is kept constant, that would not work. Now, there are three equations. Moving on to the adiabatic process for the equation, you have the heat capacity ratio. Now, the heat capacity ratio is for monatomic and diatomic, and these are the two values that you would need for that problem. Moving on to the graph, the first graph is an isobaric graph. Now, because pressure is kept constant, if we are given pressure, we can use this equation. Now, that would also equal the area under the graph, or it could be V2 minus V1. Moving on to the next graph, we have two isothermal processes. Now, between them is an adiabatic process, which means there is a change in temperature, but no change in heat. Moving on to the first example, we have an isothermal process, which means this equation will need to be used. Now, because going from V initial to V final is 1 to 4 because it is quadrupled, we can use simple numbers. Then converting the temperature to Kelvin, that is the value that we get. Plugging in the numbers that we had calculated, we get the final answer to be 12.2 kilojoules. The next example involves an isobaric process. Now, because pressure is kept constant but not given, we cannot use this equation. We must use this one. Converting the change in Celsius to Kelvin would give us the exact same answer, so we do not need to convert temperature to Kelvin. Now, plugging in the given numbers and doing T final minus T initial gives a final answer of 1.80 kilojoules. The final example is an adiabatic expansion problem with argon as the gas. Argon is monatomic, which means the heat capacity ratio is 1.67. Plugging in the given values and knowing that the change in Celsius is equal to the change in Kelvin as the last problem, we do not need to convert, giving us a final answer of 360 joules. And that is the topic of work.